What a pleasure to be here, and I really appreciate the invitation. And I also now know what happens if you go over time, and it will slap you down. So I will try to finish on time. So what I'd like to do today is really cover three areas. First area, a little bit about our program, the Vehicle Technologies Office. Second area, specifically about our collaboration with Tardec. And thirdly, a little bit of sort of look ahead, things that we're interested in going forward. So diving right in. So what are we interested in? Department of Energy, we're interested in oil dependency and ending it. When you look at oil, transportation is responsible for 2/3 of our petroleum consumption here in the US. And if you look at the transportation portion of petroleum consumption, 80% of that is on-road vehicles. It's the vehicles you and I drive every day, the vehicles that deliver goods and services. So that means in transportation, everything else, including air, rail, shipping, even pipelines, is 20%. On-road vehicles, 80%. So you cannot address petroleum dependency without going after the efficiency of our vehicles. And then finally, transportation still highly dependent on petroleum. Enjoyed Nigel's remarks about fracking and the increased availability of petroleum products, but there are other challenges associated with that too, and I'll get to some of those. So to us, this is an economic security issue. We're spending almost $1 billion a day just on the imported petroleum we consume. It is a national security issue. It's an energy security issue. So we are intently focused on petroleum consumption and the implications of it. We do recognize right up front changing energy landscape, natural gas, electrification, and some of the technologies that have emerged that really enable some of these pathways, not to mention some of the regulatory background, such as fuel economy standards. I'll be going over a little bit of that more later. And then finally, we recognize that, sure, there's an economic standpoint, but the cost of oil is not just monetary. There are definite environmental impacts, impacts to the warfighter, as Dr. Rogers pointed out. So that is our focus. What do we do? We're primarily an R&D organization. We work on technologies that will improve that picture. We do that primarily in two different ways. First, from an efficiency, this pointer does not work too well, does it? Or really at all. The efficiency, I'm okay, I can go without it, thanks. The efficiency of those vehicles, so we're still working on combustion efficiency. There's a lot you can do there to improve the efficiency of the vehicles, running on conventional fuels. Vehicle lightweighting, sort of the tide that raises all ships, no matter what your propulsion system is. Lightweighting can help you out, and of course I mentioned electric drive. Fuel substitution, biofuels. Now, within DOE, we have 3 programs that work on transportation. The Vehicle Technologies Office, of which I'm a director, is almost everything having to do with vehicles. There's a fuel cell and hydrogen office that's obviously the fuel cell propulsion systems. But the third one is bioenergy, and so they look at production of biofuels. And then natural gas and electricity, all things that can directly supplant petroleum. And then finally, deployment, and I'll talk a little bit more just briefly about deployment. So it's budgetary-wise, a minor part of what we do, only about 10% of our budget, but a very important part, because I think, earlier when Nigel talked about maybe not having a complete span of control, but being able to influence things, we have a little bit of a different aspect. Yes, we have very fortunate to have some budget authority to work on these problems and develop technology, but ultimately our goal is to get it to the market. And so deployment becomes a critical part of that. And our partnerships with industry play into that also. But we run the Clean Cities program with almost 100 coalitions nationwide, which help push alt-fuel vehicles and infrastructure into the market. Like Dr. Rogers, to us, the student and getting technologists into the marketplace that are familiar with these technologies is critical. One of the ways we do that is sponsoring. We have a 25-year history of sponsoring advanced vehicle competitions. We were thrilled earlier, just in the last month, to announce EcoCar 3, our next iteration of that competition series, and with the vehicle platform being the Chevrolet Camaro. And I would be remiss if I didn't point out that competition series and EcoCar 3, our joint headline sponsor with that is General Motors. Very pleased to work with them. And that competition series is run by Argonne National Laboratory. We run fueleconomy.gov along with our friends with the Environmental Protection Agency, one of the most popular websites in government, and a key way that we get information out to the public. And finally, the Clean Fleets Partnership, which tries to work with the 100 largest fleets in the U.S., representing over 1 million commercial vehicles, to push alt-fuel vehicle. In the introduction, we mentioned EV Everywhere Grand Challenge, announced by the President in March of 2012, with the goal of enabling electric drive technology to be directly economically competitive with conventional vehicles, and to do so by 2022. We published an update document with some recent successes available on our website called The Road to Success. We also launched the Workplace Charging Challenge, which is working with employers to place charging at places of employment. A key thing, because only about half of us have access to off-street parking. So if you're going to look at the next place that people have their vehicles parked, a lot of the time it's at places of employment. We're thrilled that we have 70 members now. And I did want to give a little bit of a shout out to the Supertruck program. So our program is light duty and heavy duty. And on the heavy duty side, our flagship project had been the Supertruck project, working with 4 integrated teams, including Cummins, Daimler, Navistar, and Volvo. And the Supertruck project, the overall goal of the project is to increase the freight hauling efficiency of Class 8 long-haul trucks, those are the 18-wheelers that everyone sees on the highway, by 50%. And roughly from a mileage standpoint, that means going from about 6.5 miles per gallon to almost 10. And so when you consider that these vehicles are already the most efficient vehicles on the road, that's a pretty, what we thought would be a very astounding, almost too difficult goal to reach. But the good news is all these teams are on track to reach that goal. There's really 2 parts to it. One is the freight hauling efficiency goal. The other is the engine goal to reach 50% brake thermal efficiency. All the teams are on track to do that. And earlier this year, just I think it was February, Cummins unveiled their Supertruck vehicle that is in on-road testing right now and has achieved 10.7 miles per gallon. That's a loaded truck, 65,000 pounds. I know 65,000 pounds doesn't impress you. I mean, you talked about 40 tons, 80 tons, was it? Yeah, 80 tons. Yeah, well, we wouldn't get it 10.7, I don't think. Okay. So major collaborations. So collaborations are absolutely critical to us. If, you know, as Dr. Rogers pointed out, you know, it's great to do some good science, some good technology development, but if you're not moving that technology into the market, you're not achieving anything. And so to us, the way that we have to be responsive to the various markets is through partnerships. I'm going to talk quite a bit about our partnership with Tardec, the Advanced Vehicle Powertrain Technology Alliance. But I also want to mention the China Energy Research Center, if for no other reason than it's led right out of the University of Michigan, so we're proud of that. Our 21st Century Truck Partnership, which works with all the major truck manufacturers and suppliers and for government agencies, including the Army, and US Drive, our light-duty partnership, which works with Ford, General Motors, Chrysler, Tesla, 5 major oil companies, and 3 utilities to shape our goals and targets and shape our research agenda in the light duty space. So, collaboration with Tardec. So I wanted to say historically, this really built on an existing collaboration and partnership with the Army, which dates back quite a while, but which mainly focused on engine and fuel technologies. And we really wanted to broaden that collaboration across the full breadth of vehicle technologies. I did want to mention that this was launched in 2011. We heard from Senator Levin this morning, but he was there at that launch, as was then Secretary Chu and then Undersecretary Westphal. And the whole idea about this alliance is to achieve greater value between the Army's work and our work on a collaborative basis. Now, it might be easy to sort of assume, you heard from Dr. Rogers, they're working on vehicles, they're interested in efficiency, we are too, isn't the intersection obvious? And the reality to that is perhaps maybe not as obvious as you might think. As you heard in the previous presentation, the Army's vehicles are very specific, quite a bit different. We're very interested at VTO in reducing petroleum demand, and we focus on the consumer market. Those are the vehicles that are using that petroleum on the road that we talked about. Tardec, I loved your catchphrase at the bottom one of your slide of your job to help the warfighter do their job and to bring them back safely. I paraphrased, but something like that. And I've sort of built on that a little bit to say that bringing them back safely, that energy usage is a piece of that. There's a price to be paid for delivering energy on in the battlefield. And so there is an intersection here. It's real, and we have built on that to broaden our collaboration, and I'll just talk a little bit about that collaboration. So obviously we do the easy things. There's a lot of information exchange going on. We jointly review projects. We work on solicitations together. We work on planning activities. We are thrilled to have a U.S. Army liaison, Bill Harris, sit in our office space. That is invaluable to us to provide continual collaboration and to identify new areas to collaborate on. We are coordinating on research activities of mutual interest. I'll talk about a couple of those. And we are joint funding some specific R&D projects and have jointly made selections and managed some projects through our open solicitations. So that has been a great success for us, and harder than you might think. Yes, we're both government, but doing a solicitation jointly is tough work. So a few of the kind of areas we're working on: lightweight vehicle structures, joining technologies, of course, thermoelectrics, rare earth materials for motors. I'll talk about that in a moment. I mentioned multi-material joining. Lubricant formulations, that's a sort of a no-brainer. That's something that we can both use directly. Computer-aided engineering for batteries, a big area for us. And finally, breakthrough techniques for dissimilar materials joining. I mentioned multi-material joining, but we've specifically have some projects looking at some sort of out-of-the-box thinking on that. So those are some examples, and I'm not going to go in any detail on all of these, but I did want to I have two slides here. Two slides for two purposes. One is to demonstrate just a little bit more detail about a couple of these projects, but also to demonstrate that the depth of our collaboration has reached a point that DOE is now doing some quad charts. So the Army can appreciate that. We're not doing them well, but we're doing them. Okay, so in the non-rare earth materials, in the area of electrification, If you're not familiar, about 95% of our rare earths are imported from China. It is a huge cost implication. When you do the breakdown of what an electric drive motor costs, about 50% of it is the materials cost of the magnets. And so being dependent upon that foreign source of that material and such a large expense is a huge deal. And so we have quite a bit of work underway to look at reduction and or elimination of rare earth and permanent magnet motors, as well as alternate motor topologies and approaches that don't use rare earth. So this project with the Army coordinates a lot of that activity and is designed to end with demonstration of some of those non or reduced rare earth motors in the vehicles that are of interest to us. The other one I wanted to mention is for a slightly different reason. In the DOE, we have had a multi-year project looking at the computer-aided engineering for energy storage technologies. And this was really originally an attempt to marry all the various models that go from sort of the atomistic scale all the way up to full scale batteries. A lot of different models exist to sort of be able to marry those together into a software backbone that would join them all, and you could do a much better job of engineering energy storage technologies computationally. So we had already launched that effort when we launched the collaboration with Tardec, and we were thrilled that for a very modest amount of cost, Tardec was able to piggyback on our work and make that work directly relevant to them. So I put that up there as a success, that here's something that we were doing anyway. We didn't ask Tardec to pay a portion of the cost per se, except for the part that was going to be relevant to them and provided the value to them. So a great success there. Okay, now I'm going to shift. How am I doing on time? Okay, all right. Last third of my presentation, I wanted to look ahead a little bit. And now I'm not going to, I don't pretend that this is going to be all-encompassing, that this is everything in the future that we are looking at or should be looking at, but just hit on a couple highlights that are of interest to us right now and I think bear a little bit of emphasis. And also I would note that there's a lot here that you heard Nigel talk about early on. So I'm going to focus on the items in red. CAFE, fueling infrastructure, vehicle miles traveled, and vehicle automation and connectivity. The other items I think are important to us. They're always in the back of our mind. We're just not going to talk about them now. Oil prices and the way that affects the vehicle market, that affects the drive for efficiency and consumers' willingness to essentially pay a little extra for a more efficient vehicle is always there, but we're not going to talk about it. Renewable fuel standard, it's in the news quite a bit in the last 6 months, but we're not going to go there. Zero emission vehicle mandates in California, a huge driver, and a lot of the vehicles, compliance type vehicles coming out, but I won't otherwise talk about it. And then economic growth and wealth and natural gas use in transportation. I'll only touch on natural gas insofar as we talk about fueling infrastructure a little bit. So I want to touch on a couple of the technologies that we see as being really critical for CAFE. This is not rocket science. Anybody in the room probably could have presented or come up with these slides, but it is sort of the way we're thinking about it, and so I wanted to share that with you. So obviously downsize engines, a continuation of the downsizing trends and boosted engine technology is going to be real important. We do think that this intersection between downsizing and turbo or supercharging strategies with electrification is something that not a lot of people are talking about, but which really represents a really good opportunity. And if you're not familiar with the High Boost project, you might want to look that up and just see what they did. So this idea that as you start to have a little bit of energy storage on board the vehicle to accomplish stop-start or micro-hybridization, that it might enable supercharging, for example, to further downsize engine technologies, because otherwise turbo technology doesn't help too much on the low end of the power range. So you see that intersection of those two technologies not really being taken advantage of yet, but likely to be. Obviously, lightweighting. The poster child for this was the Ford F-150 with 700 pounds taken out using aluminum. And so you'll see a lot of aluminum work. You'll see more and more high-strength steel. And of course, high-strength steel has been moving in to vehicles for a long time, but you're going to start to see more second. And we're working on third-generation high-strength steel. So that's going to be really important. And then carbon fiber composites and magnesium. Those obviously moving in a little slower due to cost. But certainly those are the four that we're working on most. And I think historically we've always used that 10% lightweighting resulting in 6 to 8% increase in fuel economy as a sort of rule of thumb metric. But we have some recent work showing that really the fuel economy benefits can be higher than that. So we'll be sharing that in the next year. Electrification. A big deal. I talked about mild hybrids and stop-start kind of technology, but we do think electrification right now is, to a large degree, being driven by CAFE and the zero emission mandate in California. And the good news is battery costs are declining very quickly. Just in the last 5 years, about a 70% decrease in our battery cost model. This is a high volume modeled cost, not a purchase price, where we were over $1,000 per kilowatt hour just a few years ago, and now at about $325 per kilowatt hour, and still going down. So the battery costs have come down. They're going to continue to come down further. And it's really being done not through manufacturing technologies really or volume, being done by increases in energy density and improvement to the electrochemistry of the technology. And pretty much all of that is lithium ion. Ultimately, our goal is $125 per kilowatt hour. That's a difficult goal to meet. Certainly, I won't say impossible. We think that you can definitely get to around $200 per kilowatt hour, maybe a little lower, but $125 per kilowatt hour with lithium ion is tough, might require a beyond lithium. Plug-in sales are up quite a bit. 2012 versus 2011 was a 3x improvement. Not surprised since there really weren't many models available in 2011. 2013, 2x over 2012, and this year we're running at about a 20% increase in sales over the first 4 months of plug-in vehicle technology. So electrification is important and will continue to grow. And I just wanted to make sure you knew that, we know that there's a lot of other important CAFE technologies. We're just not going to talk about them all here. We have projects in low rolling resistance tires. We've got no 32-speed transmissions, so I'll tell you that. But there are obviously a move for higher speed transmissions and other energy efficient engine technologies in the market. And a lot of people don't talk about aerodynamics too much because there's so much been done and the OEMs have such a great handle on that. But there are further gains that can be had there. So my last real subject today is fuels. So this is not a Photoshop picture. This is the real, I think this station's in Kansas. They offer 10 different fuels. Granted, 4 or 5 of them are diesel, but still. And the point I'm trying to make is right now when you talk about fuels technologies and niche vehicles, you will hear people talk about different kinds of diesel and biodiesel, natural gas, CNG, LNG, E10, E85, propane, plug-in vehicles that have a couple different charging standards in play, level 2 charging, level 1 charging, DC fast charging on top of that, hydrogen, 5,000 PSI, 10,000 PSI, and liquid hydrogen, all different types of regular gasoline, premium, and diesel. And you even hear people talking about methanol and DME, essentially, gas to liquid type products. And so in a way, this is exciting. There's more choices than ever hitting the market, and that's a good thing. But the challenge is that there are almost 150,000 service stations in the US. Every one of them right now has at least gasoline, and many of them, probably 15% of them, have gasoline and diesel. A very, very small fraction have anything else. And the consumer expects ubiquitous availability of fuel. And so accessing the broad market beyond niche markets, because any one of these fuels works great in a niche market. You hear about people putting in LNG for long-haul trucking, propane in some small fleet. Certainly natural gas is 50% taken over the refuse hauling business. So there are successes, but they're all centrally fueled, pretty much. They're either centrally fueled or hub oriented. And so accessing the broader consumer market and doing it for a fuel that is not ubiquitously available is going to be tough. And so I just bring this up as something that's both exciting, but also something that represents the infrastructure challenge that is formidable indeed. I forgot. I have 2 more slides, but I'm done. I'm good on time. All right. So just wanted to mention trends in travel demand. Vehicle miles traveled actually has kind of leveled off. A lot of people talk about this, and the next slide, the share of 15 and 19-year-olds that have a driver's license kind of declining as being hugely impactful. And I think it is in a way. Nigel talked about urbanization, and I think correctly put it that not in the U.S. perhaps not the impact that it is globally, but definitely a trend. And so the difference between the growth in social networks, the urbanization is putting a little bit of downward pressure on vehicle miles traveled and driving in general. But I only put it up here to sort of show that we recognize this, that it's certainly impactful to our thinking. I do not believe this spells the end of transportation or light-duty vehicles or trucking. I think this is a fairly near-term effect. Last slide. Connected and automated vehicles. DOE does not have a huge role in this area, but we are very interested in the energy impacts of connected vehicles. And so we're doing some work in that area to understand what those impacts are, both negative and positive. And a big thing looking forward, obviously. And I will finish there, and thank you so much for your attention.